Hi folks, so this is part 2 of the video of solving LC-416 partition equal subset sum. And in the previous video I explained the basic solution for this one. In this video we'll discuss the optimized version of this solution. So when you submit it, we saw that we got DLE, right? And this is the video you need to watch if you want to see how we can optimize this, right? Okay, so I've used it as a test case. Now let's think about how we can optimize it. So definitely we are going to use, in this case, we are going to use a memoization technique, right? And we'll store our computations and reuse them to optimize our solution, right? So one important thing before we start coding that we need to know is that, see, in my recursive call, there are two parameters that are passed and based on which I am playing, right? One is my index and another is my target sum, right? So, like, you need to understand that when you're storing these computations, the variation would also depend on, since it is depending on 2D, like two parameters. So your array or your storage is going to be a 2D array also. So this is the difference that we need to, like, understand, that when to use a 1D array and when to use a 2D array. In cases when there was no other parameter, right? Like when we discussed, I think in the previous videos where I discussed minimum cost of climbing the stairs. So there was no other factor involved. It was just the steps, right? Just the indexes. So we used a 1D array. लेकिन इस केस में, since there are two parameter based on which my code is working, so we have to use a 2D array. Okay, also let me know in the comments if you want me to do a English video. Like, I know I'm communicating in English, but I'm obviously, like, we all are Indians. Hindi is our matrabhasha, or maybe it is not for some of you, but yeah, mine is. So if you want me to talk in English, let me know in the comments, right? Okay, okay, without going any further off the topic, let's see how we can optimize this one. Okay, okay, so first thing is that I need to store in a 2D array. Now what do I need to store? I need to store true or false. Okay, so let me make a boolean array, 2D boolean array, and let me make it. Now the two dimensions on which it depends is, one is the sum and another is the nums, right? So first thing that I need to do is I will use in one dimension for rows nums dot length, and for the sum, since we are passing sum by 2, so let me just make this target clear to you so I can do it like this. Yeah, this is what my target sum is, so that's why I'll be using target here. Target. Okay, one more important point to keep note of is that here I have to use target plus 1. Why do I have to use target plus 1? Okay, try removing target plus 1 and just keep target. You'll see that you'll get index out of bound exception. Why? Because see, let's say in this case my target is 22 by 2, that is 11, right? So you're going to go to the index 11. Now, since the total size of the array is 11 only, and we know that it is zero indexed array, so there is actually no array for index 11. It is size of 11, where indexing is from 0 and it is going till 10, right? That is why I have kept target plus 1 here. I hope it is clear. Okay. Now I need to pass this to this one. Okay. Uh, all right, one more thing here before we go ahead and further change it. See, here the solution that it is returning is either a true or a false. Both of these are absolutely valid answers. Now, what we generally do is that we initialize our DP array with a value which is not a possible answer. But in case of a primitive boolean, it can be a true and it can be a false, right? So, how can I check that what to return or what to initialize it with? So what I generally do, I myself, I mean, there are other ways of also doing it. You can use an integer array and play out with two values. But what I do is that I keep a wrapper boolean array and we keep it here. Just like we have integers for int and long for like with a capital L for long type of primitives. Similarly, we have it for boolean also, and this is specific to Java. So what it basically does is that it will initialize the array with null values, and based on that, I will do the check in my function. All right, so that is why I have kept it capital B boolean. Okay, I hope it is clear. Now I have passed it, and let me go to the function and also include it in the parameters. I'm going to use it here, and I'm going to use it here. Okay, and now what I'm going to do, I'm going to check here that if my dp nums dot length and target plus 1 is what we have decided, right? So that means if my dp this would be I, and this would be your sum. So sum should not be equal to null, right? If it is not null, then return dp I and sum. All right. Okay. Now let's also get it from here. dp I sum. All right. So this is my 2D array. Nums dot length and target plus 1 is what I've kept the size as. Then in this one, what I'm doing is that for I and sum, I is what I am keeping it as the index, right? And sum is what I'm keeping as the index for my column. That is why dpi sum. I think that is all. Let's try running it and see if it is working. Okay, awesome. It is working for this case. Yeah, so this is the case that I wanted to show. Saying now we are not getting TLE anymore, right? So this is accepted. Let's try submitting it. Awesome, it got accepted. Okay, so just a quick recap of the important things in this question. One is when you're doing a DP solution for this one, we are like, I am using a capital Boolean, wrapper Boolean. You can do it with integer values, 1, 2, and then map it to true, false, and initialize it with some other 3, 4, whatever. I am just keeping things simple and using default null initialization for capital Boolean, right? Another important and very important part is that this is going to be a 2D DP array because your parameters on which your computation depends are two. That is why 2D and not just one dimensional array, right? I think that is all for this question. So I hope this has made sense for you. Let me know your comments in the comment section, of course, and I will see you in next video. Okay, bye bye.